So if you recall from previous notes, we found that we could undistribute more than just a number or a variable from an expression, but we could undistribute an entire set of parentheses. So we looked at an example just like this one before, where hopefully we see that x minus 5, that entire set of parentheses, is in common in both parts of this problem. So I can factor out that x minus 5, and then I have to figure out what's left behind. So if we imagine that this is gone, then that means remaining behind from the first part of the expression is 7x, and then in the second part of the expression is just this plus 8. So this is a way that we could undistribute something other than just a number or a variable. Now that's going to be important for the type of factoring that we're looking at today, factoring by grouping, which is really just going to be a whole bunch of rounds of undistributing, the last of which will look like what we saw up here. So in factoring by grouping, what we're going to do is we're going to split the problem up into two parts. Now if you look at the example that we have here, we can already see it's different than most of the other factoring that we've done, because instead of there just being 2 parts to the expression or 3 parts, we now have 4. So that's the signal that factoring by grouping is going to be the technique that's going to be necessary. So I'm going to split the problem in two. So in the first half of the problem, I'm going to undistribute anything that I can. So 4x cubed plus 8x squared, I'm going to be able to undistribute a 4. Hopefully we can see that that's in common in both pieces. And then also both parts of the first half of the expression of these first two terms have an x squared in them. And so then I've got to figure out what's left behind. So 4x squared times x will get me back to 4x cubed if I was to remultiply. And then 4x squared times 2 will get me back to 8x squared, like we see up above. So I've undistributed from the first and second terms. So I've done kind of step 1 of my process. And so now I need to do the same thing for the second half here, where I'm going to have to figure out what can I factor out from both 5x and 10. Now hopefully we see that 5 divides evenly into both of those pieces. And so left behind inside the parentheses on this second half of the problem, 5 times x would get me back to 5x, and then 5 times 2 will get me back to 10. So now I've completed the second step, where I've undistributed from the third and fourth terms, from the back half of the expression. And so now I'm on step 3, which is representative of what we saw up here, where now if I look at the two parts of the expression, we can see that both of them have an x plus 2 in them. So I'm going to undistribute an entire set of parentheses. So I'm going to take out that x plus 2, and so if I cross those off, well, what's left behind? We can see we've got 4x squared from the first part of the expression, and then plus 5 from the second. So this is step 3 here, where we undistribute the set of parentheses and then see what we're left with. And so then we end up with almost a reverse FOIL type of answer, but we got there through these multiple rounds of undistributing. So we can take the same approach here like we did on the last one, where we've got z cubed minus 6z squared minus 7z plus 42. I've got 4 parts to the expression, so we're going to have to do these multiple rounds of undistributing, this factoring by grouping. So we're going to group these first two terms and factor there. So z cubed minus 6z squared, hopefully we see that z squared is in common with both of those pieces. So what's left behind inside the parentheses when I take out a z squared? Well, z squared times z gets me back to z cubed, and then minus 6 times z squared would get me back to the 6z squared. So step 1 is done. Step 2 now, I need to factor from this second set of terms. Now I need to end up with this exact same thing left behind in the parentheses after I have factored out whatever it is I'm going to factor from that second half. I have to end up with z minus 6 left behind. So when I look here at this negative 7z plus 42, I'm going to undistribute not just a 7, but I'm going to undistribute a negative 7. Because if I undistribute a negative 7 from both these pieces, negative 7 times a positive z is going to get me back to this negative 7z. And then negative 7 times negative 6 will get me back to positive 42. And so for this last round of undistributing, so after I've undistributed from the first half and the second half, for the last round of undistributing to be possible, I have to have the same thing in both of these sets of parentheses. Otherwise, I can't do that last round. So that's the trick. If we ever see that there's some subtraction there in front of that third term, almost always that means we're going to end up factoring out a negative instead of a positive term. But if we've got this far, now we can see, hopefully, that we do indeed have z minus 6 as being the common set of parentheses. So that's what's going to get taken away from both of these parts of the expression. And so then what's left behind? Well, in the first part, it's z squared, and then in the second part, it's minus 7. So in the last one, again, step 1, I need to undistribute from those first two terms. So hopefully we can see that y squared is what is the common factor. So y squared times y will get me back to y cubed. Y squared times 2 will get me back to 2y squared. Now I need to factor from the second set of terms. So here, once more, because we see this subtraction here, and we need to end up with y plus 2 in the parentheses, I'm going to need to factor out a negative 9 from both those parts. And so if I take that out and take out a negative 9 times positive y gets me back to negative 9y. Negative 9 times positive 2 gets me back to negative 18. So I need to make sure that whatever I end up with in both sets of parentheses is a match. So indeed we have that. So now I'm going to undistribute that entire set of parentheses. So I'm going to take out that y plus 2. And so then what's left behind from the first part of the problem is y squared. And then from the second part of the problem is a minus 9. Now hopefully we're noticing that although maybe this y plus 2 isn't going to go anywhere, y squared plus minus 9 is still factorable. This is a difference of two squares. Y squared is a perfect square, and 9 is a perfect square as well, and those two perfect squares are being subtracted. So we have a pattern that allows us to factor that expression. So we need to make sure that we factor completely. So I'm going to have to factor one more time. I've got y plus 2. That term, I can't do anything with that. But now that y squared minus 9 is going to factor into y as the first piece in each set of the parentheses. I'm going to have 1 plus and 1 minus, and then the square root of 9 is 3, so it's going to be plus 3 and minus 3. And so here now is our fully factored expression. So not only did we have to factor by grouping, but we also had a difference of squares after we finished that factoring by grouping. So we had to do a little bit more factoring to get that y plus 3 times y minus 3.